The optogenetics precursors Gero Miesenböck, Ed Boyden and Karl Deisseroth have arrived in Madrid. Tomorrow they'll receive the BBVA Foundation Frontiers of Knowledge Award in the Biomedicine category for developing this technique that produces extraordinary findings in neuroscience.
And I think optogenetics has really catalyzed this transition of neuroscience from an observational discipline into an interventionist one.
It was in fact Miesenböck who first proved that it was possible to control neuron activity with light by introducing light-sensitive proteins and thus activate only the desired cells. Deisseroth and Boyden perfected the technique with proteins derived from algae. Now, a decade later, optogenetics has been universalized and has become the most accurate technique for studying a live brain. With it, you can explore functions like sleep, appetite, or some illnesses, such as epilepsy, as Boyden explained.
And one hope is that, especially for developmental epilepsies that affect people early in life, that you could try to study these by creating small circuits in vitro, in a dish, and then using this to screen for better drugs or to personalize a treatment for a person.
Furthermore, clinical trials based on optogenetics are being carried out in visually impaired persons due to retinitis pigmentosa, to replace cells that were destroyed in the retina, replaced by light-sensitive cells. There is still much progress to be made in this revolutionary technique that aims to understand the basic principles of the brain, insists Deisseroth.
Is help us build the understanding, the basic fundamental understanding of how the brain works. And that is the most exciting thing that's happened over the past few years, and I think the greatest area of growth into the future.
A promising technique that in the not-too-distant future could answer the unknowns of the brain and give solutions to some mental illnesses.